So students, last class we did the Rutherford's atomic model. You have seen the drawbacks of the Rutherford's atomic model. So Rutherford could not say anything about the stability of an atom. Alright, it was challenged by Maxwell and his atomic model was discarded. We can say that. And also Rutherford could not explain anything about the different types of series, the atomic spectrum and all those things which you will be studying in the higher classes, so to say. So he could not explain about all those things. Now, coming today's topic, Rutherford's student was Niels Bohr. Now Niels Bohr was a Danish physicist. Alright, Danish physicist, we can say that. Niels Bohr was. Clear? So, not a chemist, let me tell you, physicist, because this chapter is there in physics also, atomic structure. Now what he said, got it? Listen carefully. So he said that we are having a nucleus which consists of the neutrons and the protons, which is positively charged, and around the nucleus we are having shells. Alright, shells, not cells, S-H-E-L-L-S, cells. Alright, around the nucleus we are having different shells, which we called this as energy levels. Alright, the shells he called it as energy levels, energy level, we can say that, or we can say it as orbit, we can say that. Clear? So he said that we are having a nucleus where definitely, as I said you, the Rutherford discovered nucleus. The most of the mass, the entire mass of an atom is concentrated here because it consists of the neutrons and protons, and electrons is moving around the nucleus in a shell which is having a definite or a discrete amount of energy. They are also called as energy level, we can say that. Clear? They are also called as energy level. And this energy level was also designated, means it was also named. Like as you can see, this is your first shell, this is your second shell, this is your third shell. In this way we can have 4th, 5th, 6th, 7th, up to 7 we can have, because there are 7 periods in the periodic table. Later on, when you will study the periodic table, you will come to know that number of periods corresponds to number of shells. So you cannot have infinite number of shells. Understood? Maximum you can have 7. Okay, fine. So the first shell was named as K shell. We can say that. The second shell was named as L shell. L. Then M. Then N. In this way it went on. The first it started from K. Now you may ask why it started from K. Why Niels Bohr was not knowing ABCD or what? He could have started from A, B, C, D. Why it started from the middle? That is K. Now K has come from the, what you can say, Latin language. K means kernel. K-E-R-N-E-L, kernel. And in Latin, kernel means it is first. In Latin language, kernel means it is first. So hence it is K, L, M, N, O, P. In this way it goes on. Got it now? Why it started from the what you can say letter K? In this way, the first shell he named it as K shell, the second is L, third is N, M, N. In this way it goes on. Okay. Now remember it. What I said to you, this is energy level. So the shell which is nearest to the nucleus, the first shell which is nearer to the nucleus, it has got a definite amount of energy, a fixed amount of energy it has got, a fixed value of energy. You will study about it in class 11, that what is the fixed value of energy it is. Generally, it is nothing but calculated as minus 1312 kilojoules per mole. The first shell, the energy has. Now you may ask from where I got it. Now this is not there in your this one. You will be studying in the higher classes. So En is equal to minus 2 pi square Me4 Z square by N square H square. This is the formula, isn't it? Now pi 22 by 7. M is the mass of the electron, which I said you already, 9.11 in 10 to the power minus 31 kg. E is the charge of an electron, which is 1.602 in 10 to the power minus 19 coulomb. Z is the atomic number. Last class I said you, number of protons is equal to number of electrons. N is the number of shells, energy level, and H is your Planck's constant. You'll be studying about it. Planck's constant. That is, Max Planck was a scientist who gave a value of constant. Its value is H is 6.626 into 10 to the power minus 34 joules second. So all these value when you will put it, and the value of N as 1 you will put it. N as 1, the first shell, which is called as the energy in the ground state, the first shell known as. Alright, so you will be getting the value to be as the first shell, the first orbit, we can say the value you will get it as minus 1312 kilojoules per mole. We can say that. Now here many of you asked, what is mole? Mole is nothing but a unit which is used to measure the what you can say, or which is used to relate between the different atoms, molecules, ions, gases, then solids, liquids in chemistry lab. Alright, because in chemistry lab we are using different kinds of substance. Like see, when you are going to a market, you are buying eggs. What is a unit to buy the eggs? Dozens. You are buying potatoes. What is a unit? Kg, gram, in this way. Suppose you are buying oil, isn't it? You are buying in what? Liters. Suppose you are buying pen, you are buying in what? Scores, numbers, scores. So you can see different substances have got different unit. But the unit which you are using in our, the substance which you are using in our day-to-day life, the unit are not interrelated. It has got no relation with one another. Like a liter of petrol has got no relation with potatoes. Potatoes has got no relation with dozens of eggs, nothing. They are all independent of each other. But listen carefully. In chemistry, the solid, liquid, gas, atoms, molecules, ions, whichever you are using in the chemistry lab, they are all interrelated because the numericals are there, the problems are there upon it. For example, suppose if I ask you based upon this, let me tell you a little bit about moles, then you will come to know. Let me ask you, suppose a given reaction is there, zinc solid plus H2SO4, which is aqueous. Aqueous means liquid. Dilute. Gives what? It gives you ZnSO4, which is again a solid, and hydrogen gas is released. A gas. So you can see in one particular reaction, solid is there, liquid is there, gas is there. Three things are there. Are we having a day-to-day life these things? In one particular, what you can say, reaction. First of all, are we having in a day-to-day life some reactions? No. So the units are independent of each other. They are independent of each other. As I said you, suppose if you want to buy potatoes, should you know that what is the dozen of eggs? Or the relationship, there is any relationship between dozen of eggs and potato? Or there is any relationship between potato and the pen? Is there any relationship between pen and the petrol? No, nothing. They are all independent of each other. So we did not have to know the relationship. But here it is required. How it is required? Suppose if I ask you that I am giving 5 gram of zinc, I am giving you. You tell me what is the volume of hydrogen gas evolved. So there is a relation between gram and liter or milliliter. There is a relationship. Suppose I am giving you 5 gram of zinc. I am asking you, you tell me how much of sulfuric acid is required. What is the weight of sulfuric acid required to react with 5 gram of zinc? Again, there is a relationship between mass and mass. Alright, in this way, there is a relationship. In one particular equation, you can say solid, liquid, gas is there. I can ask you the number of atoms. You will be doing this sort of questions when you go to higher classes. Between number of atoms, number of molecules and all those things. You will be doing these questions. So, mole is, now listen carefully. So, mole is that particular unit. I am not saying the definition of mole. You learn it in higher classes. A mole is that particular unit which establishes a relationship between the substances used in the chemistry lab. Relationship between what? Solid, liquid, gas. Like as I said you, 5 gram gives how much volume of hydrogen. To get this, you need to convert into moles. Then only you will establish a relationship. Alright, you will be establishing a relationship, and by using that relationship, you will be able to solve this particular question. So again I repeat, mole is what? Mole is nothing but a unit. Mole is nothing but a unit which is used in the chemistry lab, which establishes a relationship between atoms, molecules, ions, solid, liquid and gases. Again, let me tell you, this is not a definition, this is just a simplification of the mole. Alright, I am not defining mole, I am explaining you what is mole. Definition you will read it later on. Alright, so understood? What is that mole? Mole means a unit here. Here kilojoule per mole is what? What is this? It's nothing but a unit. It's a unit. Alright. Like in our day-to-day life, as I said, different units are there. Similarly, in chemistry lab also, there must be a unit which establishes a relationship between solid, liquid, gas, atom, molecules and ions. So that is a unit. I hope you understood a little bit about it, mole. Alright. Now, next is, as I said you, that by using this formula, then this formula was given by Niels Bohr. It was experimentally calculated and this formula was being taken out. It is not there in your level. Got it? You did not have to know about all these things. So when you put the value of all these things which I said you, value of H, value of N as 1 if you put it, M the mass of electron, charge of electron, atomic number, pi value you will put it, then you will get the energy of the first shell, the first level, which is minus 1312 kilojoules per mole, and this energy is considered to be as the energy in the ground state. That means it's a minimum amount of energy. Remember it. Alright, it's a minimum amount of energy. Clear? And as you are going from the first shell to the outermost shell, the energy what happens? Increases. Energy is increasing. Alright, energy is increasing. Remember that when you are going from the first shell to the outermost shell, the energy increases. So electrons, for that reason, which are present in the outermost shell, they are known as valence electron, because the outermost shell is known as the valence shell. What I said you? Valence shell, the outermost shell is called as a valence shell, and the electrons which are present in it, they are called as the valence electrons. And always remember that in a chemical reaction, the valence electrons only participates in a particular reaction. Alright, in every chemical reactions, the valence electrons only participate. Innermost shell electrons, they are not participating in it. Why? Because innermost shell, the electrons which are present, innermost shell, let us say this is the outermost shell, these two are the innermost shell. Now they are held strongly by the nucleus. Why? Because nucleus positive, electrons is negative, so there is an attractive forces. But what happens to the outermost shell? The outermost shell, the electrons are free. So to say, they are considered to be as free electrons. Why free? Because I said the energy is maximum. So if the energy is maximum, what you find is that they are free, these electrons are, and hence they are liable to lose from the outermost shell. So every chemical reaction, whenever it is taking place, whether the loss of electron, suppose it is going to take place from the outermost shell. Suppose electron, if it is going to gain, if the outermost shell is going to gain, then the electrons is gained by the outermost shell. Suppose a sharing which is going to take place between the two atoms during chemical combination, that is taking place from the outermost shell. So outermost shell determines the chemical reactivity of an atom, the outermost shell. That determines, so hence that particular shell is called as a valence shell. So the valence shell determines the properties of that particular atom, whether the atom is a metal, non-metal, inert gas, metalloids, and whatever it is. Got it? How it is? If the number of electrons in the outermost shell is 1, 2, 3, it is metals, because it has got a tendency to lose. How? I'll tell you. If the outermost shell has got 5, 6, 7, then it is non-metals. Alright? If in the outermost shell it has got 8, then it is considered to be as inert. We can say that. Inert in nature, because the outermost shell is fully filled. And if it has got 4 electrons in the outermost shell, 4. Now 1, 2, 3 means it has got tendency to lose. It is a metals. 5, 6, 7 tendency to gain. It's a non-metals. We can say non-metals. And 4 means it is a metalloid, because it can lose or it can gain. Either it can lose or gain. So it is considered to be as metalloids. You'll come to know. When I finish this particular chapter, everything will be clear. Don't worry about it. Alright. And 8 means it is inert. Means outermost shell is fully filled. It will neither lose nor it is going to gain electrons. Fine. Let me come again back to the postulates. So the postulates means the points which I was talking to you about the Niels Bohr's atomic model. So what I said you? He said that the first shell is a K, then L, M, N. In this way, energy increases as you are moving away from the nucleus. Energy is increasing. So the electrons which are present in the first shell, it's considered to be the lowest energy. After that, the energy increases. What is the value? I said that this is the value. This energy considered to be in the ground state. Got it? And remember one more thing, that when an electron is present in a particular shell, it neither loses nor gains energy. It neither loses nor gains energy. So if an electron is present in a first shell, it will continue to remain in the first shell only unless and until you provide energy to it, or it loses energy. Alright? Listen carefully. If an electron is present in a particular shell, it continues to remain in that particular shell with a fixed amount of energy. It continues to remain unless and until some energy is being provided externally, or it loses energy. Alright, it will remain in that particular shell. Remember that. So Niels Bohr suggested that when an electron is present in a particular shell, it neither loses nor gains energy. Alright, it neither loses energy continuously nor it gains energy continuously. It has got a fixed or a definite amount of energy. So it continues to remain in that particular shell unless and until some energy is provided. So when some energy is provided, listen carefully now. If it gains energy, What it will do? It will jump, it will not move. Use the word jump from lower energy level to the higher energy level by gaining energy. Very simple it is. By gaining, it will jump from lower to higher. And by losing energy, it will come from higher to lower. By losing energy, it will come from higher level to the lower level. So the change in energy delta E is equal to E2 minus E1. E2 is definitely greater than E1. We can say that. E2 is greater than E1. Here, if it is jumping from lower to higher, so it is gaining energy. So E2 minus E1 will do. Alright, if it is coming from that is it is losing energy, then it is come from lower, what you can say higher to lower, then it is going to lose energy. We can say that. Clear in this way. Now next is the energy level is discrete. You can't see the energy level. Understood? You don't see the energy level. It is not like a concrete that you will be seeing. This is discrete. Discrete means what? Hidden. Chipa hua. Alright, discrete, and the value is quantized. Quantized means what? Fixed. The value is quantized. It's a fixed value of energy. Okay. More about it I will say in the next video. Thank you.